Hello students, in the previous class we have already discussed resonance. In this class we shall discuss sharpness of resonance. So before going through the topic, first let us understand what this graph is saying. So first of all recall something, that what is resonance. If an AC voltage V is equal to V naught sin omega t is applied to an RLC circuit, then I becomes I naught sin omega t plus phi. At resonance condition, total reactance of the circuit becomes 0. Hence Z becomes Z minimum, that is impedance attains its minimum value as well as current attains its maximum value. Now if current is maximum, then I naught is also maximum at that particular frequency. So at omega is equal to omega naught, that is our resonant frequency. I naught is also maximum, so I naught is also equal to I naught max. Now this is the curve for the I naught. That is, at different frequencies the I naught value will be something like this. That you must be now thinking that how come I naught is dependent upon omega. Recall that I naught is equal to V naught. Okay, let me go in detail. I is equal to V by Z implies I naught sin omega t plus phi is equal to V or V naught sin omega t by Z. Z means R square plus XL minus XC whole square root over this much. Now you think amplitude is this much. This is the amplitude of the right side. This part is amplitude, that is V naught by this much, and left side amplitude is I naught. That means I naught is equal to this part. In this part omega term is there because XL is omega L and XC is 1 by omega C. That means I naught is dependent upon omega. That's why this curve is coming. Okay. Now at omega is equal to omega naught, at omega is equal to omega naught, this part becomes 0. If I write I naught is equal to V naught by this much, at resonant frequency this part is 0, so only part will be R square root over, so that is R, and it will become I naught max because impedance is minimum. So I naught max is equal to V naught by R. This is this point. At resonant frequency I naught is I naught max. Okay. Now what about these two frequencies, omega L and omega H? Now let us try to understand. Omega L is the frequency where I naught max becomes I naught max by root 2, and omega H is also another frequency at which the value is also the same. So this range of frequencies over which the value is between I naught max by root 2, okay, and I naught max, this is the range. This range of frequency over which the value is always above I naught max by root 2. This is called bandwidth. Okay, BW means bandwidth, and bandwidth is equal to omega H minus omega L. Omega H is called higher cutoff frequency and omega L is called lower cutoff frequency. So what we get here, that is omega L is equal to lower cut off frequency and omega H is higher cut off frequency. These are the frequencies at which the I naught attains a value I naught max by root 2. Now this is the relation, we need it in our derivation. I naught max is equal to V naught by R. Now let us try to understand what is sharpness of resonance. What is sharpness? Now look, resonance is the condition when I naught attains its maximum value. Now look, if this frequency is not constant, this frequency is varying, then if it is varying means sometimes it will be below I naught max in this direction or it will be in that direction. If omega increases, it will go in this manner, or if omega decreases, then it will go in this manner. Okay, that means there is a range of frequency over which the value is maintaining its value over a particular value, that is I naught max by root 2. Then within that bandwidth range, I naught max is only one point, one single point. Practically it is not possible to maintain a constant omega naught value. It is very, very difficult. That's why we always choose a range of frequency, that is bandwidth. That means a system will be at good resonance condition if this bandwidth is very, very small. So our objective will be to keep this bandwidth very, very small. In that case, this curve will become a sharp curve. Okay, if it becomes narrower, then it will be pointed like. So in that case, the more it is pointed, the more sharp is the resonance. In other words, less is the bandwidth, more sharp is the resonance, or sharper is the resonance. This is called sharpness of the resonance. It is measured by a quantity called quality factor. Quality factor, that is Q, and its formula is omega naught by bandwidth, resonant frequency by bandwidth. Now you see, omega naught is constant, it is resonant frequency. Now more the bandwidth, less is the quality, or less is the bandwidth, more is the quality. Less bandwidth, more is the quality resonance, okay, or sharp resonance. Now we shall derive an expression for Q in this class. Let us derive it. So first of all, I'll write what is the formula for I naught. I naught is nothing but V naught by Z. This is equal to V naught by R square plus omega L minus 1 by omega C whole square root over. Now when omega is equal to omega h, when omega is omega h, this one, then I naught will become this much, I naught max by root 2. So I will simply put here I naught max by root 2 is equal to V naught by root over of R square plus, in place of omega I have to put omega h. So this is the condition. So omega h L minus 1 by omega h C square root over. Now this implies, what is I naught max? I naught max is V naught by R. V naught by R root 2. This is equal to V naught by R square plus omega h L minus 1 by omega h C whole square. Now V naught gets cancelled from both sides. So remaining part will be, after that, after cancelling V naught, we can square both sides. On the left side it will become R square 2R square. On the right side it will be R square plus omega HL minus 1 by omega HC whole square. Now from this, one r square on the right side, another, there are two r square on the left side, so one will cancel out with one r square from the left. It will become r square is equal to omega HL minus 1 by omega HC whole square. Implies square square gets cancelled, so omega HL minus 1 by omega HC will be equal to r. Now here you look, keep this term as it is, minus omega h. Okay. Now one thing I might be missing here, omega h. Yes, let us replace first omega h. Let us replace it first, omega h. Then what is omega h value first of all? Omega h. Okay. Now omega naught and omega h. What is the difference here? This difference is nothing but bandwidth by 2. Total range is bandwidth. Bandwidth is equal to omega h minus omega l. Implies I can write bandwidth is equal to omega naught, omega h I have to replace. Okay, let me be direct. I can write it directly also. This range is omega h minus omega naught is equal to bandwidth by 2. It will be simpler. Implies omega h is equal to omega naught plus bandwidth by 2. Okay, I will replace this value here. So omega h is nothing but omega naught plus bandwidth by 2 whole into L minus again 1 by this much omega naught plus bandwidth by 2 whole into C. This is equal to R. Now one more thing, what is omega naught formula? Omega naught is equal to 1 by root over of LC. This implies if you square both sides, it will become omega naught square is equal to 1 by LC. Implies C 1 by C is equal to omega naught square L. We have to use this equation also here in place of 1 by C. So it will be, this part will be omega naught plus bandwidth by 2 into L minus, in place of C I can write 1 by C omega naught square L divided by omega naught plus bandwidth by 2 is equal to R. Okay. Now from this equation, one more thing, next step implies omega naught L plus, if you write it like this, okay, I'll write it later, not now. Let it be as it is, L minus. Now here you come, here I have to apply binomial theorem here. So let me erase these things. Here I can write omega naught square L divided by omega naught. Take omega naught common. So it will be 1 plus bandwidth by 2 omega naught. This is equal to R. Now 1 omega naught cancels. So I can write it as this part omega naught plus bandwidth by 2 into L minus omega naught L. Then I can write it as 1 plus bandwidth by 2 omega naught whole to the power minus 1, because it was in the denominator. This is equal to R. This implies omega naught plus bandwidth by 2 into L minus, I can apply binomial theorem here. Then outside it is omega naught L, so inside the bracket it will be 1 minus 1, not 1, it will be NC0, N is minus 1, so first term will be minus 1. I am not going in detail for binomial theorem because it will take more time. Minus 1, then minus NC0, then the first term, that is first term is 1, I think, sorry, first term is 1. Then second term is NC1, so it will be minus this term. So if you are not clear about binomial theorem, I will explain you in another class, okay, but not now. Now this is the value here we are getting after using binomial theorem. So it will become, now open this, omega naught L plus L into bandwidth by 2. Now if you multiply it, it will become omega naught L plus omega naught gets cancelled. It will be bandwidth into L by 2, bandwidth into L by 2, then this is equal to R. Now omega naught L gets cancelled, implies this one plus this one, they are same, so it will be L into bandwidth is equal to R. Implies bandwidth is equal to R by L. Okay. Now quality factor formula was omega naught by bandwidth, implies quality factor is equal to omega naught by R by L. So this is the final formula of quality factor. Okay. Now if you be more specific, then it will become L by R, omega naught is nothing but 1 by root over of LC. This implies Q is equal to root L, so 1 by R root over of L by C. Okay, so this is all about your sharpness of resonance. More the value of Q, more sharper will be the resonance. Okay, thank you.